Today I'll be presenting our Design Variation Modeler, also known as DVM. Like VA, DVM is in SOLIDWORKS, Creo, NX, CATIA V6, 3D Experience, CATIA V5, and our software Multicad. So we're completely integrated, just like VA. It's just a little bit more slimmed down, easier to use. Jumping to this next slide here, so our 3DCS scalable solutions. This is kind of a Venn diagram of what we have included in all of our softwares here. So if we look at this red circle, DVM, if you're familiar with our VA software or if you've used it before, these are icons in our software, which I'll show in our demo pretty soon here. So with our DVM, if you're familiar with VA, you might recognize that move icon right there. That's our feature move icon. So in DVM, there's not going to be any points. It's all feature based. So all of our moves, GD&T measures, they're all only using the features. You're not going to be able to create points anywhere. So that's where you will see the points icon in MVM and in VA, and not in DVM. We also have GD&T still, but you can also see we don't have form. We only have location and orientation in DVM. So back over here, we have two types of measures in DVM, which I'll talk about in the demo also. But just to give a quick overview of those right now, we have a dimensioning location measure and a GD&T measure. This is our DVM software, so you may recognize some of these symbols like I talked about before if you're familiar with VA. So the main thing here is it's a lot more slimmed down, so we don't have all the symbols that Variation Analyst has. We still have the main symbols like I mentioned before: nominal build, separate, deviate, animate, moves, GD&T measures. We have our update model button over there. We have a show mesh, which I'll talk about a little bit more in detail if you have not seen VA before. But the big thing is we don't have show points, like I said. There's no points in DVM, and that's just meant to kind of make it a little bit easier on the user, so you can just use the features to fully build a model a little bit faster than in a VA. So a little bit about this magnetic transfer switch assembly model. We have our salmon colored piece here, which is called our base. We then have our green piece here, which is called our metal insert. And then we have our blue jumper piece over here. So we're going to jump straight into creating some moves here. So like you can see over here, I already have my moves created, but I'm just going to cover just a little bit about those here. So over here on the right, I'm going to click on that move button. And if you're familiar with VA, when you click that move button, you'll know that it asks you, or our software 3DCS asks you where you want to put those moves in your tree over here on the left. As you'll notice here, this just automatically popped up to put in the top assembly. So that is one thing with DVM. You're going to put your moves and your measures only in the top assembly. So that's another way we're kind of simplifying our DVM software as opposed to our VA software. You can only have your moves and measures in the top assembly here. And again, with this drop down, we only are using the feature move in DVM. So that's why we only have just this one option here, just again to simplify the software a little bit, make it a little bit faster and easier to use. So we're going to just take a look here. So this first move I have, bringing the metal insert to the base. This is pretty similar to the feature move in VA. The only real difference is we're only going to be using one object target pair per primary, secondary, and tertiary pairs there. So in VA, you can add multiple features. In DVM, you're only adding one per box here. I'm going to close out of these here, and we're just going to animate through these moves quickly. So again, our first move is going to bring that metal insert to the base. Our second move is going to be bringing the jumper to the metal insert. And then from here, we can kind of start taking a look at the goals for our model, our GD&T. So our goals would be our measures. So I'm going to jump back to that PowerPoint quickly. I have a slide on our model goals here. So this model is actually used in our tutorial for DVM. So this picture right here is taken right out of that PowerPoint. So the goals of this model is to pretty much find this gap right here. We're going to just kind of track that gap and look at our results there. So we want to see if we can stay within that plus or minus 3 from our nominal of 4. Also look at this 4 plus or minus 2 on the right side of that jumper to the base there. And then these two measures right here, those kind of go along with the GD&T measure, which again is going to be covered in a future webinar, so I'm not going to talk too much about those. We're going to mainly focus on this one right here. So I'm going to jump back to the model here. But before we get to measures, I'm going to talk a little bit about GD&T. If you are familiar with VA, you'll notice that I do have GD&T here, and like I said, we're only having location and orientation in DVM. But the overall creation of GD&T is pretty much the same as VA, but I'm going to cover just a little bit of what our software is doing with the GD&T applied in this model already here. So if you're not familiar with VA at all, this is your first time seeing any type of 3DCS software, you'll want to listen here and I'll talk a little bit about it. So over here on the top left, I just clicked on this Show Mesh button, and you'll kind of see this spider webbing effect on the surfaces used in the moves, measures, and GD&T. So I'm going to zoom in a little bit right there. So this surface right here with the spider webbing effect has a surface profile of 1 applied to that already. So what I can do over here is just press this deviate button, and you'll see that mesh is actually moving off of that surface. So what we're doing here is we're actually applying that surface profile to the mesh itself, not the actual surface. So we're varying that mesh, not the nominal CAD. And then also, if I were to nominal build here in our move metal insert to base there, we're bringing this metal insert and touching it up to this surface that we're talking about here. So if I were to deviate, we can see that that green part is actually moving with the mesh itself, not the actual salmon colored base here. So what that's doing is just kind of representing our 1D stack through the base to that metal insert with our surface profile of 1 applied there. And I'll zoom out here and turn that mesh off and nominal build again and just deviate. So this is kind of just taking a look at all of that GD&T we have applied in our model, which I will cover a little bit of GD&T addition. We're going to be creating a new measure after we take a look at results, just to see how simple it is to add a new measure in here. So I will cover a little bit about that, but for right now, we're just taking a look at what is actually applied so far. And again, we're kind of looking at this gap up here so we can see how that's changing right now. So I'm going to go ahead and nominal build my model again. So we want to take a look at measures. So again, down here, this measure button, we'll give that a click, and that's again going to put our measure straight at the top assembly, just to kind of simplify our overall model here in DVM. And like I mentioned in the PowerPoint, we only have 2 measure options in DVM. So as opposed to VA, where we have many more measures, and it's most beginning users don't really get to all the more complicated measures. This is more of a simplified way, just a few easy measures for simple measures like this. So like this surface to surface there, we're going to be using the dimensional distance measure. So I'll talk a little bit about that one just by clicking on this first measure. So this is going to be our jumper to base X measure, which is that one that we've looked at in that PowerPoint there. It's going to be this surface to that surface. So in DVM, it's fairly simple. We're just going to be clicking on our base surface there and our jumper surface there. You can see it highlight in the CAD. Again, we want to stay within that range of 6, so plus or minus 3 there. And the way that this dimensional distance measure works, since this was released in 7700, so some of you might not be too familiar with this dialog here. A normal, in VA, we have the option to possibly type in a direction if we don't like this default direction. But this default direction is just coming off of this primary, or this first face we're using in our measure. We do have the option to use a custom direction, and you can pick a direction. So if I just select any face, that would be the direction we would be measuring in here. But I'm happy with that first face there. That's the direction we want. Another thing to notice in this dimensional distance measure is if I were to press this add all here, and this drop down is defaulting to surface, so that's where we clicked on these two surfaces. We also have the option to do point at click. And what that's going to do is this is kind of going to be the only time in DVM where you can kind of use points. So wherever you click is going to be the spot you're going to be measuring from. So instead of using the kind of feature center locator point up here, if I jump into this second measure where we use that point at click, wherever you click is going to be the spots you measure from there. So it's a little bit more of a precise way to measure. Say if this surface on the base was off at an angle like this, you wouldn't want to measure from the center here. It wouldn't give you an accurate representation of that gap there. So you'd want to use this point at click to kind of a little bit easier find where you're measuring from there.
Ethan, do you just want to really quickly show actually creating or using the point at click so it's clear?
Yeah, I can do that. Let me just create a new measure here. So again, you're just going to want to press that add all button. I'm set at point at click. So let's say we want to measure from the back surface here of that jumper right here to the, here I'll nominal build that, the back surface of that jumper right here to the surface down here on the base.
Okay.
So I'm going to go ahead and just zoom in on this corner here, and I'm just going to give it a little click, and if I highlight the mesh there, you can kind of see that point there. So that's really the only way we can have points there. I'll go ahead and kind of estimate where it would be on the base there. And I'll nominal build and show features. So that 3 and 3 is where we are going to be measuring from. But it's pretty simple to use that point at click. Just wherever you click is going to be a point, and we'll be able to measure from those instead of just using that feature center locator point there.
Yep.
I'm not gonna save that measure or anything. But again, I'll be creating a measure. We're gonna take a look at results here, and then I'll be creating another measure and creating some GD&T just for this side over here. So I'm gonna go ahead and make sure my model is nominal built. And then we are going to go over here and press our Run Analysis button. So this window looks a little bit similar to our VA software. We can see that we have our validation succeeded, our assemblies built, our scale is equal to 1. So we are checked out on all of those. But the main difference here in DVM versus VA, so in DVM we're going to be using an equation-based analysis with worst-case scenario, where in VA we're going to be using Monte Carlo analysis. So we will see a little bit different of a histogram. It's not gonna have the bars in it. It's just gonna have a histogram based off of the calculations done by the equation-based analysis. Go ahead and run that. And I'm going to go ahead and just click on this first top measure that we were kind of looking at previously. From here, we can see that our nominal is at 4. Our upper spec limit is 7, and our lower is 1. So we can see it on the histogram here. And then we can see that our estimated range gives us a lower limit at 0.86 and then an upper at 7.13. So which gives us an estimated range of about 6.27. We wanted to stay within that range of plus or minus 3, so we want to stay within the range of 6. So we're a little bit out there, so we're actually total percent out at 0.41% there. We can also kind of scroll up to the about midway up there. We can see min worst case, max worst case, and range worst case. So our absolute worst case possible between this gap is actually a crashing through at negative 5.47, and then a max worst case at 13.47 with a range of 18.94. And then same with VA, still we see our contributor list down here. So we can see that our number one contributor to our data up here is the position jumper holes of this T jumper XY hole in the metal insert. So that's actually going to be, if I zoom in here a little bit, that's actually going to be this rightmost hole in the metal insert. So what I can do here is if I right click on that number one contributor, I can press this visualize effect button. And again, I want to just look at that T jumper XY, which is our top contributor. So what I'm kind of doing here is I'm just isolating just that right hole in the metal insert. And I'm going to be deviating that from its minimum value to its nominal to its max value in both the X and the Y directions, since it's a hole. And we're going to just take a look at what just that tolerance has an effect on for our gap measure up here. So if I just press this continuous button, we can see that that position on that hole is going up and down and then side to side. We can see how much that affects our end gap up there. We can also see that we have a geofactor here, which is also in our VA software. Which is just a good thing to look at because we can see that we have a fairly high geofactor of almost -3 there. And what that's telling us is it's kind of acting like a lever effect here. So if this position were to change just a small amount, since this measure location is so much farther over to the right, we're almost getting like a tipping effect. So we're kind of this is where 3DCS kind of overcomes a 1D stack. You wouldn't really get that same effect in an Excel 1D stack. So that's where that visualize effect comes in. We can see, oops, I'm doing all both of those holes there. So we can see that it's just kind of tipping right there, and that's where that geofactor is coming from.
Yeah, so if you were doing a 1D stack, you'd probably just be translating that jumper part up, right, and down instead of actually twisting it about some axis. So that's where you get some advantage there with DVM over a 1D stack in Excel.
Yep. All right. So we're just going to quickly take a look at creating a new measure here. So as you can see, like we have a full model built here, full GD&T, full moves. We have the measures we want to look at, but say we had the idea that we want to actually take a look at the distance from this left side of this jumper to the inside of that base right in there. 3DCS makes it very simple and easy in DVM to actually create a new measure here. So what I'm going to do is just add a new measure. So I like to just right click, add measure, and then dimensional distance is what we want to look at here. So I'm just going to add that. So I'll just call this new gap measure jumper to base. So again, I'm going to use surface to surface here. So I want to make sure I'm on surface to surface, not point at click. So I'm going to go ahead and just select that surface on the jumper and then mouse over to the base and click that inside surface there. And I'm just going to give some spec limits of 1.5 and negative 1.5 there. I want to check my direction. Direction's taking off that first feature I've selected, and that is the correct direction. So I can go ahead and press OK here. And since this is a new measure, I don't have GD&T created for these two new surfaces I'm selecting just yet. So what I want to do is just go into the jumper. I'm going to add a new profile tolerance here. And I'm just going to select that same surface for the measure. I'll keep it at 1 to ABC. I'll give it a name of profile new measure surface. And I can press OK there. I'm just going to do the same thing on the base down here. Find my base in the tree, add a new profile tolerance there. And we'll just give it the same name. Keep it at 1 to ABC. And then again, we can just build our model, run our equation-based analysis here, and then just take a look at our results. So it's that simple and easy. Just that took me maybe a few minutes just to create a new measure here and create some new GD&T. And we get our full data, our full contributor list, just like the other measures that were already in this model.